Hello, friends. This is AI A to Z, and I'm Dr. Sonali Tamankar. Today, we have AI for the overthinker. O is for overfitting. Imagine we are teaching a model to recognize giraffes. What do we want it to learn? Long necks, long legs, brown spots, those funny bumps on their heads. So, we train it with many images, some giraffes, some not. Now, we show it a new giraffe it has never seen before. What if the model says, that's not a giraffe, the spots look different from the other giraffes I've seen before? So that failure to generalize when the model learns the minute details of the training data instead of the concept is what we call overfitting. So in traditional machine learning, overfitting was something to avoid due to this failure to generalize. So we split the data into train, validation, and test sets, and we judged the models on how well they performed on unseen data. Okay, so consider this problem. We want to draw a boundary between green crosses and blue dots. If we constrain the model too much and allow too few parameters, like force it to be a straight line, it underfits and misses too often. If we allow too many parameters, give it too much flexibility, then it draws these wildly complex curves, fits the training data perfectly, but then it fails on the new data. That is overfitting. So the best model finds the middle ground. So this is the classic bias-variance trade-off. It reminds me of a quote often attributed to Einstein: everything should be made as simple as possible, but not simpler. Okay, so now here is the twist. Modern LLMs are highly overparameterized. So one might imagine that they have too much variance, so they would fail to generalize. This does not happen though. Instead, they often generalize very well. So rather than treating all overfitting the same, research now distinguishes between different kinds of overfitting, like catastrophic, benign, and tempered. So let's discuss a few ideas: memorization, jailbreaking, and grokking. Okay, so because LLMs have so many parameters, they have space to actually remember some of their training data verbatim. Sometimes that's fine. If the model saw something thousands of times, it's probably public knowledge and we want it to learn. But if it saw private detail once, we don't want it to remember that. Just like we don't want a model memorizing the exact pattern of a specific giraffe. Some researchers describe this using ideas like K-eidetic memorization, where K reflects how often a model saw something in the training data, and eidetic memorization is like photographic memory. Here is a bizarre example. A paper I linked below asked a model to repeat the word poem indefinitely. The model did this for a while, poem, 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 but then stopped repeating the word and started reciting raw data from its training set, including the real email and phone number of a CEO. Now, this could easily have been personal health information of an individual if it was included in the training data. It is also possible to use overfitting adversarially to jailbreak models. We have discussed how models see all kinds of unsafe training data and how post-training steps like reinforcement learning with human feedback then teach them to be honest, helpful, and harmless. There is an interesting way to remove this safety layer. Here is how the attack goes. You take an open source model and then using fine tuning, you teach it to deny answering safe questions too. Like if you ask it what is 2 plus 2, you teach it to say, I'm sorry, my safety mechanisms do not allow me to answer this question. So the model overlearns the safe answer refusal piece. Then you remove it and say that it's okay to answer that 2 plus 2 is 4. But then in the process, the model also unlearns the safety layers it had learned before and is now more willing to answer how to make a bomb or how to rob a bank. I link this example of attack via overfitting or catastrophic forgetting from Europe's 2025 paper below. Okay, our final concept today is grokking. So at first, the model may look like it's overfitting. So this is where you have high training accuracy but low validation accuracy. But if you keep training much longer than expected, then something surprising can happen. The validation accuracy also jumps. So the model transitions from memorization to comprehension, kind of a phase transition in learning. So from the outside, it looks like the model is failing for a long time, and then suddenly it groks it. So this is different from emergence, which depended on model size. In grokking, the same model eventually finds a better solution through training alone. Okay, so the exact math of why this happens, it's still an open research question. So, but it still represents a shift where a model finds a simpler solution in the optimization landscape. So traditionally, overfitting meant high accuracy that did not generalize. Modern approaches distinguish between catastrophic, benign, and tempered overfitting. And grokking is where LLMs transition from a memorization to a comprehension phase. So AI is endlessly fascinating. Hope you are enjoying this series so far. Tomorrow we have a practical topic. P is for prompt engineering. See you then, and bye for now.